By the way, you need to do the practice test. There's practice test on paper and there is practice test on WebDesign. The WebDesign practice test, I decided to make it available starting today. So it is available now. And the WebDesign practice test is going to be graded, and the grade is going to be calculated as part of your assignment grade. So that's kind of required. But the paper one is not required. And so, you know, if you have to choose, I would say choose the one on the WebDesign, because you will be penalized for not doing it. But I'll be taking questions on both on Monday. Next Monday will be basically discussion of questions you may have from the practice tests, both practice tests, the paper one and the WebDesign one. So the paper reason for the paper one is, you know, WebDesign, the problems I find on WebDesign are not, you know, all kind of problems you would expect in the test. The choice is limited there. So on the paper, I can put down any of my question that I want to ask in the test. I can put any question on the paper. So that's why the paper is more thorough than the WebDesign practice test. I recommend doing both if you have the time. If you have to choose, then do the WebDesign one. Okay, moving on. In the last class, we learned how to find the permutations by using box method. So I'm going to start from there. Permutation, let me begin with the notation for permutation. We learned the notation P and R, but there are other notations I need to bring up. So P and R represents number of ways of permuting or arranging R objects taken from N. So N objects, these are the number of objects given. These are the objects you're choosing and arranging. So a number of arrangements are being counted. That's what this is. There are other notations, N superscript, P, and then R subscript. This is another notation. It means the same thing as P and R. Also, some books use N, P, R, all same level, no superscript or subscript. So all of these mean the same thing. So we did these exercises in the last class, P94. To find it, we said, okay, this means number of ways of rearranging 4 objects chosen from 9. So we said, all right, then that means we can use 4 boxes because we're choosing 4 objects and arranging them. So a number of ways of arranging them is same as number of ways of filling in these 4 boxes. So therefore, we can calculate it by doing this. How many ways are there to place one of the objects here? 9 ways. There are 9 objects to choose from. And then the number of permutations will be same as number of ways of arranging or code words without repetition. We understood that in the last class. The permutations are same as arrangements without repetition. So therefore, no repetition allowed. So for the second box, 8 ways to do, 7 ways, and 6 ways. So multiply them, that'll be your number. But today, we are going to learn how to derive our formula from these. So therefore, I'm going to ask you to write these answers as these products. We learned how to write these products in terms of factorial. Can somebody tell me what is this in terms of factorial? We can write a product of numbers as division of factorials. We did that in the last class. So can somebody answer this question? I want to write this product as a division of 2 factorials.
9 factorial over 5 factorial.
9 factorial over 5 factorial, exactly. So let's leave it at that and go on to the next question. Question 13 says find P94, and that would be 95. sorry, P95. So that means 5 objects are chosen and rearranged. That's same as number of ways of filling 5 boxes with 9 letters without repetition. So there'll be 9 times 8 times 7 times 6 times 5, and that's equal to factorial 9 over factorial 4. Okay, let's do one more. P10 4. That'll be 4 boxes and 10, 9, 8, 7. The product of that will be the answer. That's equal to factorial 10 over factorial 6. Okay, so now let's look at these numbers. The numerator is always same as the number of objects given. 10 objects given, numerator is 10 factorial. The denominator is 5 factorial in this case, same as 9 minus 4. Here is 4 factorial, same as 9 minus 5. 6 factorial, same as 10 minus 4. So basically what I'm showing you is that P and R is same as factorial n in the numerator, factorial n minus R, this minus this in the denominator. That's how they are happening. You can see the pattern. So this is our formula. So now we have a formula that we can use to find permutation of any numbers. This method of box method, you can always use that if you want, but for larger numbers, this formula is convenient. So if I want to find, for example, permutation of 50 objects given, 3 at a time. So now using the formula, what's the numerator? Anybody?
47. Wait, you said numerator?
Numerator,
Would be 50.
50 factorial divided by
47.
47 factorial, which is equal to 50 times 49 times 48, if you remember. Everything that comes after that will cancel with the 40 and 47 factorial. So you multiply that, and that's your answer. That's same as using box method. If I'm using box method, I'm looking to arrange 3 objects, so 3 boxes to fill, and 50, 49, 48, because no repetition allowed. As you can see, they are identical, no matter whether you use the formula or the box method. Now, by the way, remember the permutation is same as arranging letters. So same as making code words with the letters without repetition. So only if the problem has to do with no repetition, then it's same as permutation. If repetition is allowed, then the only method you can use is the box method. You don't have this permutation formula in that case. You can still do those problems with repetition, but box method is the only way. Okay, so now we have formula. So let's answer these questions. Exercise 14, let me clear the board first. Exercise 14 says, how many different 4-letter code words can be formed using the letters A, B, C, D, E, F? And part A is repetition is not allowed. So part A, we can do it by either permutation or box method. Both can be used. So I'm going to use permutation for part A. It's 6 letters given, and we are making 4-letter code words. That's same as saying how many ways are there to arrange 4 letters taken from the 6. So it's same as permutation of 6 comma 4, which is equal to factorial 6 over factorial 2, and that's equal to 6 times 5 times 4 times 3. And you multiply them to get the answer. Part B says how many such code words can be formed if repetition is allowed. So if they allow repetition, then box method is the only way. It's not permutation anymore. So 4 boxes to fill, because the code words are going to have 4 letters, and 6 ways to fill the first one. How many ways for the second one?
6.
6 and 6 and 6. Repetition is allowed means you it's the same number. So 6 to the power 4. If the boxes are like 10, then it's 6 to the 10. So that's when you need to use the calculator to find the exponent. All right. Now, I already explained this. Only if repetition is not allowed, then the problem is same as permutation. If repetition is allowed, then you can only use box method. So the next question is asking you to find the values of these basically by applying formula. So let me just go over 15b and ask you to tell me the numbers. What are the numbers for P11.5? Apply the formula. Anybody?
Factorial 11 divided by 6 factorial.
6 factorial, right. And then you go on to simplify. When you're doing this on web design, you have to simplify and enter the final answer. Let's do the part C, which is P55. So what do I get for the numerator?
Factorial 5.
Factorial 5. And denominator is?
Factorial 0.
Factorial 0. Okay, so now we are running into a question. What is factorial 0? Well, factorial is defined to be the product of, going back to the original definition, it's the product of all the numbers starting from the given number down to 1. So we said, okay, then factorial 5 is 5 times, 4 times, 3 times, 2 times 1, and that's 120. But then factorial 0, we can't go down from 0 to 1 because 1 is higher than 0. So the definition doesn't apply. So we just have to come up with the right value that will make sense in terms of our problems. So here is how we're going to find it. P55. P55 is factorial 5 over factorial 0. But if you use the other method, the method of box method, then there are 5 boxes to fill. 5 objects are given to us. So how many ways are there to fill the first one? 5. And no repetition, because permutation is same as arranging without repetition. So 5, 4, 3, 2, 1. That would be equal to factorial 5, right? So if I apply the formula for P55, I'm getting factorial 5 over factorial 0, but the correct value is factorial 5. By using the box method, we figured that out. So therefore, this factorial 0 should be 1. Only then these two will match, right? They have to match. So for the formula to work for this kind of situation, the factorial 0 should be 1. So therefore, mathematicians decided to define that factorial 0 is 1. You know, the factorial 0 doesn't fit into our definition, so we have to figure out what value would make it work for all of our problems. Only if I define factorial 0 as 1, then our problems will work. I mean, we can do the problems using the formula only if we agree on that. So therefore, that is the value, and you need to remember that factorial 0 is 1. Okay, so let me clear the board. So the key point we learned today that you need to remember is factorial 0 is 1. So therefore, if you look at P44, that's equal to factorial 4 over 0 factorial, which is same as factorial 4, according to our value, because of the value of factorial 0. So now we can, let me ask you this question then. Pn comma n for, we just saw P55 is factorial 5, P44 is factorial 4. So what is this? Pnn for any n. What can you say?
N factorial.
N factorial. So no matter what the n is, Pnn is always same as n factorial. All right, now let's answer some questions. We can use common sense to answer these questions in exercise 16. The first one says, find P12(1). We will apply the formula to verify, but think about this in terms of, real situation. There are 12 objects given, and you're taking one at a time and arranging. So if you take one, there are no rearrangements. So basically it's that same as saying, in how many ways can I select one object from 12 objects? How many different ways are there to choose one object from 12 objects? Anybody? If I give you 12 pencils, in how many ways can you choose one pencil?
12.
12. Well, you choose either first one, second one, or third one. All the way there are 12 of them. Any one of the 12 can be chosen. So therefore, 12 ways to do that. Common sense, right? Let's apply the formula and verify. That's what we are getting. P12(1) by the formula is factorial 12 divided by factorial 12 minus 1, which is 11, and factorial 12 over factorial 11 is equal to 12, right? Everything that comes after 12 will cancel out with the factorial 11. So verified. Part B is P60. 60. Let's think about it using common sense. 6 objects are given. We are choosing nothing. In how many ways can I choose nothing from 6 objects? One way, choose nothing. So answer should be 1. Let's use the formula to calculate. Numerator is factorial 6. Denominator is? Anybody?
Factorial 6.
Factorial 6. 6 minus 0 is 6. And that's equal to 1. So it matches common sense. How many ways can you choose nothing? One way, choose nothing. Okay, part C says Pn1. What is the expression for Pn1? Anyone?
N.
N factorial over?
N minus 1 factorial.
Minus 1 factorial. What will I get if I simplify this?
N.
N. Because n factorial means n times n minus 1 times n minus 2 all the way down to 1. But everything starting at n minus 1, n minus 2, all those will cancel out with the denominator, right? So you will end up getting n. So let me write down, if you to make it clear, n times n minus 1 times n minus 2 all the way down to 1 divided by factorial n minus 1. The factorial n minus 1 is same as n minus 1, n minus 2 all the way down to 1. So all these cancel with the denominator. So the final value is n. Pn1 is equal to n. Now using common sense, we can see that P12(1) is 12 because you're choosing one object from 12 objects. P10(1) will be 10. You're choosing one object from 10 objects. The same way, Pn1 will be equal to n. The same n will be the answer. The next one is Pnn. We already figured out Pnn is equal to factorial n. So Pnn is factorial n. You don't really have to memorize that. If you apply the formula, you'll get that. So let's now apply that to real life questions. Exercise 17. Let's clear the board. Okay, so exercise 17 says how many permutations of 7 objects are possible from 11 objects? That'll be same as P11 comma 7, which is equal to factorial 11 over factorial 3 and 4, 11 minus 7. And then you had to simplify this. Now you know how to simplify that. It's 11, 10, 9, 8. Where do I stop?
5.
5, right? And you have to multiply those out to get the value of that. Exercise 18 says, in how many ways 6 people can line up? Okay, so now we're going to have some word problems, application type problems, where the permutation has to be used to answer. In how many ways 6 people can line up? That's same as arranging 6 letters to make code words, lining up 6 people. So it's permutation of what, comma, what. 6 objects are given, all 6 are being arranged, right? All 6 are being chosen and arranged. So it's P6X. So that's equal to factorial 6, which is 720. So 720 ways are there to arrange 6 people. Exercise 19 says there are 18 questions in the test. If a student must answer all of them in any order, then how many ways are there? He or she can answer them in any order.
I have a question about number 17. I'm sorry. How did we get the number 4 under the 11?
Oh, P11, 7 is the answer, right? 11 objects given, you're choosing 7. That's the answer. We are applying the formula to get the to simplify it. The formula is for P n r. The formula is factorial n over factorial n minus r, right? So the numerator is same as this. Denominator is n minus r. So 11 minus 7 is the 4.
Okay, got it.
All right. So so you just apply the formula. Exercise 18 we just finished. Going to exercise 19. There are 8 questions in the test. The student can answer them in any order, but the student has to answer all of them, but in any order. That means you're counting all the rearrangements of all 8 of them. In how many ways all 8 of them can be rearranged. That's P88 equal to factorial 8. Part B says, if the student must answer any 5 in any order, then how many ways are there? What would that be? What would that be as permutation? Permutation of what, comma, what?
Is it 8, comma 5?
Yes. From the 8 question, he can choose 5. He or she can choose 5 and answer them in any order means any rearrangements of 5 will have to be counted. So you choose any 5, rearrange, then choose another 5, rearrange, you have to count all of them. So that will be given by P85, which is factorial 8 over 8 minus 5 is 3, so 3 factorial. Okay, going to question 20. Jacob is a vocalist. Okay, so let me see if you can answer that. It's answer that in terms of permutation, if it is permutation.
Would it be permutation 7, comma 12?
7, comma 12 doesn't make sense. Remember the total number of objects given has to go first.
It's 12, comma 7?
12, comma 7 is right. Yeah. So because there are 12 songs to choose from and Jacob can sing any 7 of them. So how many different recitals are possible? So a recital means the order matters. Now, unfortunately, you have to worry about the order, whether order matters or not, because soon we're going to start combination. In a combination situation, the order doesn't matter. So we'll discuss that after we go into that. So there are, he can choose any 7 and he can play those songs in any order. So rearrangements of the 7, rearrangements of all 7s will be different recitals. So therefore, how many recitals are there means number of ways of choosing 7 from 12 and rearranging will be counted. So therefore it's permutation. Okay, so mixed application of permutation. So we need to do some of these. Well, actually, we need to do all of them. Number 20, start with the number 20. It says you have 8 math books and 6 computer books, and you like to fill 7 positions on a shelf with these books. First question is, if they can be arranged in any way, then in how many ways are there? So that means the computer books and the math books can be mixed and matched in any way. Then you can just add those numbers up. There are 14 books, and you need to fill up 7 openings in the bookshelf. Means you have to select 7 and arrange them in any order. So you're arranging them on the shelf. So that's why it's permutation. Number of ways of arranging 7 chosen from 14. So therefore it's P14, comma 7 for the part A, because you're not restricted. There's no restriction. You're free to choose the books in any way, in any order, whether it's a math book or computer book, doesn't matter. But for part B, that matters. Part B says if the first 4 positions have to be filled with math books and the last 3 have to be computer books, then how many ways are there? Okay, so for the math books, 4 places, first 4 places have to be used for math. So let's use 4 boxes for the math. I'm using box method first, but you can also do it as a permutation. But let's do with the box first. And then the remaining 3 positions are going to be computer books. So that's what those are. And then you need to decide how many ways are there to fill them. So first 4 boxes have to be filled with the math books. So how many ways are there for the first one?
8.
8. Now, after you put 1 math book here, obviously no repetition here, right? Because you only have 1 book of each. So once you place that 1 book here, you only have 7 more books to choose from. So 7, 6, 5. That's how many ways are there to fill those 4 with the math books. Now, for the next 3, we have to choose computer books. So what are the numbers?
6,
6,
5,
5, 4.
6, 5, 4, right? And multiply them out. Can we do them as permutation? Yes, we can. Can you see that this part is same as factorial 8 over factorial 4? Same as P8, 4. So basically, to answer this first part, you can say permutation of 4 chosen from 8 is the answer for that part. And for this part, you need to choose 3 from 6. So that's P6, 3. But then you had to multiply the 2 permutations. So you had to basically do it as a 2-part problem. First part, this is the answer. For the other one, this is the answer. And for each one of those, each one here can be combined. So that's why the product. For any one of the arrangement in the first part, all of the different arrangements in the second part can be combined. So that's why the product will be the total number. It's same as if you remember, if there are 5 ways to do first part, or 3 ways to do the first part and 2 ways to do the second part of the trip, then 5 times 2 ways are there to do the total, because each one here can be combined with each one of those. That's why 5 times 2 or 3 times 2, whichever the product. We learned that at the beginning. Multiplication rule applies whenever each one of this can be combined with all of the different ones in the second part. So this, you had to calculate the product. Okay, so going on to the next question, problem 21. How many, well, that's very similar to an earlier problem we did. So we don't have to do that. Jump to 22nd, problem number 22. All right, can anybody answer that?
That's 1.
I'm sorry, what's that?
I think it's 1.
The answer is 1.
Yeah, I think so.
Any other answer? Basically, this you had to use the letters in this word. So the letters are D, U, M. You know, you can consider them as different alphabets given to you. D, U, M, P, S, T, E, R. These are the letters given to you. And you can use all of them, and how many code words can be formed by arranging these letters. That means you're rearranging all of these to get different code words. You know, they're not going to be meaningful words. So that's why we're calling them code words. So in how many ways, how many code words can you get by rearranging these? Isn't that same as permutation? Permutation of what, comma what?
8, 8.
Right, 8, comma 8. There are 8 letters. All 8 are being rearranged. So P88 is the answer, and that will be equal to, remember, there is no repetition here because every letter is there only once. So you can only use these letters. You cannot use any other letters. So therefore, you're limited to these, and that means you have exactly 8 letters and rearranging all 8 of them. That's same as factorial 8 and multiply it out to get the answer. Going down to 23, it says how many 6-letter code words can be made using the letters of the word domina if the first letter must be D and the last letter must be M. If they give you some extra restriction like that, then it's most of the time box method. The box method is the best way to think about how to do it. You are rearranging all 6 letters to get code words. There are 6 letters in the word. You're rearranging all 6 of them. So there are 6 boxes. You can think in terms of that. In 6 boxes, you're placing these different letters. In how many ways can you rearrange them is the question. So to count the rearrangements, you can use the box method. The box method always counts the rearrangements. So therefore, whenever the problem is about rearrangements, you use the box method, and then ask the question, in how many ways can we fill these boxes? According to the problem, there are limitations. The first letter must be D, and the last letter must be M. So that means, in how many different ways can I fill the first one? And also remember,
1.
each letter can be only used once. You're using the letters of this word. So you don't have repetition of those letters. You can only use them once. Okay, so one student answered the question correctly. There are how many ways are there to fill the first one? There's only one, because the problem says the first letter must be D. So you had to put the D in there. Only one way to do it. And also we can put the number for the last box. What is that number?
M.
The letter that can go in the last box is M. So there's only one way to do it. Inside the box, you only put the number of ways to do that. The number of ways of doing the last box is one way. Number of ways to do the first box is one way. Can somebody tell me what is the number of ways to do the second box?
4.
4 is correct, because D and M are gone. We cannot use them. Only 4 letters are left. 4, and for the next one?
3.
3, 2, and 1. That's it. So it's factorial 4, also same as 24. 24 ways are there. That's the answer. So if they give you this kind of a question, then you may have to go to the box method instead of permutations. Okay, so that finishes that. And so that finishes the topic of permutations. And we're going to go to the next worksheet, which is about combinations. So let's see. The permutation is the count of rearrangements. Now we are going to see what combination means. Let me clear the board. A combination means the number of ways of choosing, not arranging, just how many ways are there to choose. For example, the very first example I have here says if you need to choose 2 from 3. So there are 3 objects given. We can represent them by ABC. Everything we do apply to any object, but we can use letters to represent them. So 3 letters are given. In how many ways can I choose 2? Well, that will be A and B together is 1. B and C together is another. A and C together is another. That's how many combinations are there. We're not counting permutation. This is combination. A and B combined. B and A is the same combination. We are not counting rearrangement. So therefore, BA and AB are same for combination purposes. Only for permutation purpose, BA and AB are different. So we only count AB, BC, and AC, and there are 3 of them. So there are 3 combinations. Let's do another example. If I give you, so before the next example, let me mention to you that the notation for combination is C, capital C, just like notation for permutation is capital P. So this problem we just did is same as number of ways of choosing 2 objects from 3. So from 3 objects, number of ways of choosing 2 will be written as C32, and that is equal to 3. That's what we found here. There are 3 ways to do that. But if it is permutation, then second question is, how many permutations are there for the 3 letters ABC? The permutations will be AB, BC, AC, and BA, CB, CA. These are the permutations. So the permutations, there are 6 of them. So P32 is 6, but C32 is only 3. So that's the difference between combination and permutation. We are not rearranging in the case of combinations. We are just taking a combination of 2 objects. So if they ask for permutation, then you have to count the rearrangements. If they ask for the combination, only combinations. So let's do a quick one, another one. C43 means 4 objects given, you need to choose 3 at a time. So we can use the alphabets to represent the 4 objects. So let's say A, B, C, D. Then how many ways are there to choose 3? That'll be A, B, C is one of them. You're not rearranging them. So the combination of A, B, and C together is 1. A, C, D, B, C, D, and A, B, D. That's it, 4. There are 4 of them. So therefore, the combination C43 equal to 4. Now, we are going to derive a formula for combination. To derive that, we're going to have to see how the 2 things are related, combination and permutation. So let me clear the board. I'm going to use this P43 and C43 as a way of seeing how they are related, the permutation and combination. P43 and C43, how are they related? By looking at that, we'll be able to understand what relationship is there between permutations and combinations, and we'll be able to derive a formula by using that. So if I, to describe these, the permutations and combinations of 3 objects taken from 4, I'm going to use A, B, C, D as my 4 objects. Then my combinations can be listed as I just listed earlier. So let me list them again. Combinations are A, B, C, A, C, D. I have it on the handout, the worksheet. I'm basically copying from there, B, C, D, and A, B, D. So these are the number of combinations. And this, there are 4 of them, right? So the count of this is what combination of 4, 3 is. This is equal to 4. So these are the combinations. So the number 4 is the answer for this question, C43. But if I ask you for P43, then you basically have to rearrange all these and count them all. So if I rearrange the ABC, I get ACB. I'm again copying my worksheet. I have them all there. BAC, BCA, CAB, sorry, CAB, and one more, CBA. So there are how many here? There are altogether 6 across. There are 6 of them. But this 6, where does that come from? That's same as saying in how many ways 3 letters can be rearranged. 3 letters, number of ways of rearranging 3 letters. 3 letters are given, all 3 are being rearranged. Isn't the same as P33, which is factorial 3, which is same as 3 times 2 equal to 6. So basically, factorial 3 ways are there to rearrange 3 objects. So this 6, I'm going to write it as factorial 3. So that's factorial 3. So the P43 is the count of all these, isn't it? Count of all these is what P43 is. Do you see that? It's same as the count 4 going down times 6 going across. 4 times 6, 24. But I want to write it slightly differently by saying that P43 is equal to this count, which is same as C43. That is same as the combination, C43 times factorial 3. Everybody's with me? There are 4 going down, 6 going across, 4 times 6 items are there altogether, 24. If you want, you can count on my worksheet right here. There are 24 objects here. That 24 is simply same as the multiplication of this number, 4 times 6 going across. Essentially same as C43 multiplied by factorial 3. So P43 is same as C43 times factorial 3. That's the point I just made. So I'm going to generalize that to get our formula. I need to generalize that. So all right, let me use the other eraser. Okay, so that means PNR, if I, instead of 4 and 3, I'm going to generalize it. So use NR. PNR is same as, anybody?
C times NR times R.
PNR times R factorial. This is factorial of
R factorial.
R factorial, that's right. This, we read this as CNR, not C times NR. That's not a product. It's a notation. So anyway, so that's the key. This is the key to deriving our formula for the combination. PNR equal to CNR times factorial R. So I want to solve for the CNR. So I divide both sides by factorial R, both sides. That gives me CNR equal to PNR over factorial R. Basically, that's our formula for CNR. To find CNR, we can find PNR and divide by factorial R. But we don't want to leave the formula this way. I'm going to go further and reduce it to another form that will be more convenient for us to use. That means I'm going to have to use a little bit of algebra here. So if you're good in algebra, you'll understand this better. the CNR. Okay, so CNR equal to PNR over factorial R. I'm going to simplify that further to get a better form of the formula. Factorial R. Okay, equal to, we already have a formula for PNR. So I'm going to put that in place of PNR, which is factorial n over factorial n minus R. So we have that in the numerator, and denominator is factorial R, this. So we have a fraction divided by fraction. So we can consider the denominator as factorial R divided by 1. So if you recall from algebra, A over B divided by C over D is A over B multiplied by D over C, the reciprocal. So I'm going to apply that. So the numerator factorial n over factorial n minus R goes first. And the reciprocal of the denominator is 1 over factorial R. So if I multiply two fractions, I multiply numerators together and denominators together. So then I get what? Factorial n over factorial n minus R times factorial R. So that's my formula for CNR. For PNR, I get factorial n over factorial n minus R, just these two. For CNR, I have this additional factor in the denominator, factorial R. That's the difference. Now, you can see that always combination is a smaller number, right? Going back to this example too, we found that if there are 4 objects given to us, number of ways of choosing 3 objects. In other words, the combination of 3 we can have from 4 objects will be these 4 highlighted in this box. There are only 4 items. Combination is the answer for combination 4-3. C4-3 is 4, but the permutation P4-3 is 24. The permutation is always larger number because you are counting rearrangements. So to avoid mix-up, you can remember this. PNR has factorial n over factorial n minus R. CNR has an additional factor in the denominator. The additional factor in the denominator will make the number smaller. So you can see that the number, the formula you have for CNR will be smaller, it'll produce smaller number because of the factorial R in the denominator. And we know that PNR is always larger. So therefore, you can now remember the difference, that if you remember that CNR is a smaller one, then you will remember that CNR is the one that has factorial R in the denominator. PNR doesn't have it. So going back to the worksheet, the formula for the combination is highlighted here. And so you need to remember that. You need to remember the formula for the permutation and the combination as 2 separate things. And the difference is the factorial R.
Can we just go over exercise 2 before we finish class?
Exercise 2, yeah. Of course, I'm going to do
Okay.
exercises right now. Yes. So you're going to do exercise 2, which is asking you to find combination and permutation. Okay, so let's do the first the exercise 2. It says find C43 and C94 by using the formula. Okay, C43 would be factorial 4 divided by factorial 4 minus 3, which is factorial 1, times factorial 3, this number. That's what we just did in our formula. Because CNR is, let me write that again. CNR is factorial n over factorial n minus R times factorial R.
Does that say factorial 1 next to factorial 3?
Yes, because 4 minus 3 is 1. Okay, n minus R factorial times R factorial will be in the denominator. N minus R in this case is 4 minus 3, and that's 1. So it's 1 factorial times factorial of this, that's 3. Factorial 1 is 1. So I know you may be asking the question, factorial 0 is 1 and factorial 1 is 1? Yes. So factorial 4 divided by factorial 1 fits into the definition. You know, factorial of any number is the product of all the numbers starting from given number down to 1. So factorial 1 means starting at 1 going down to 1, which is just 1. So that's why it's equal to 1. Okay, so that's 1. Factorial 3 is still there. And now you simplify this, that's equal to 4. We learned how to simplify, and that's it, that's 4. And then C9, 4. If I want to do C9, 4, okay, can somebody tell me the numbers? What's the numerator?
Factorial 9.
Right, divided by
9
Factorial 4.
minus 4. 9 minus 4 factorial
which is factorial 5.
times 4
4,
factorial.
right. Now, to simplify this, we learned how to simplify expression like this. You should take the larger number in the denominator combined with the 9 factorial in the numerator. So this combination can be simplified into 9 times 8 times, where do I start?
That's 6.
6. So this division is equal to 9 times 8 times 7 times 6. You write that first, and then you write the factorial 4 expanded as 4 times 3 times 2 times 1. And then you cancel common factors. The 3 times 2 cancels with 6. 4 divides the 8 into 2. It doesn't matter in what order you cancel them. So now we have 9 times 2 times 7. So 18 times 7. 126. That's how you simplify. If you don't simplify this way, if you try to find factorial 9, factorial 5 separately, factorial 4 separately, there's nothing wrong with that. But if that will be fine. You can do it that way. But if the numbers are big, you cannot find these individual factorials. So this method is necessary in most cases. Okay, so let's go to exercise 3. It says, use your understanding of combinations to compute the value. So just by using common sense, we can answer them. First question is C41. C41 means in how many ways can I choose one object from 4 objects? So by using common sense, what is the answer?
4.
4. 4 objects are given. In how many ways can I choose 4? There are 4 ways. First or the second or the third or the fourth. And if you use the formula, are we getting the same value? Let's try that. It's factorial 4 over factorial 4 minus 1, which is 3, times factorial 1. Factorial 1 is 1. So therefore, this is equal to factorial 4 over factorial 3. And that simplifies to 4. Using the method we learned for simplifying, we get 4. Okay, next question is C44. C44 means what? 4 objects given, and how many are we choosing? From 4 objects, we are choosing 4, right? Isn't that the meaning of this? Number of objects given is 4, number of objects chosen is 4. In how many ways can I choose 4 objects from 4 objects?
I'm sorry, can you answer how are we getting 4 from dividing 4 factor and 3 factor?
Oh, 4 factorial over 3 factorial. We did that in the last class. 4 factorial is same as 4 times 3 times 2 times 1, going all the way down to 1, right? And factorial 3 is 3 times 2 times 1. These cancel out.
Oh yeah, I forgot. Okay, thank
All right. So that's why 4 factorial over 3 factorial is just 4, because after the 4, everything else will be canceling with this. We did those in the last class. Okay, going to C44. C44 means 4 objects are given. We are choosing all 4 of them. So that how many ways are there? Only one way. You're choosing all 4. So there's only one way, taking all 4. So 1 is the answer. Let's apply the formula and see if we get the same answer. Factorial 4 divided by 4 minus 4 is 0 factorial times 4 factorial, this 4. 0 factorial is 1, and these two cancel out to 1. So 1 is the answer. Can you answer the question part C? C51 would be? By using common
5.
sense? What's that?
5.
5.
5 is right. From 5 objects given, you're choosing 1. So how many ways are there? 5 ways. So going to part D, C50. Okay, and the meaning of that is there are 5 objects given, and in how many ways can we choose nothing, right? We're choosing nothing, only one way, choose nothing. Again, you apply the formula, it'll be the same number. Okay, so we just saw that C51 is 5 and C41 is 4. So can you generalize that? Exercise 4 says, what is CNN? Anybody?
1.
1. N objects are given. In how many ways can I choose N objects? I have to choose all of them, so 1 way. And if you apply the formula, factorial n over factorial n minus n is 0 times factorial n. So these two cancel out, and this is 1, so the whole thing is 1. Again, using common sense, what is part A in exercise 4, CN1? CN1 would be n, right? From n objects, in how many ways can I choose 1? N ways. Comparing C41, C51, you can see that. So CN1 is n. CN0. CN0 means n objects given, in how many ways can I choose nothing? That will be 1, because choosing nothing means only 1 way. Okay, going on to exercise 5, C74. Can somebody tell me what the numbers will be?
4 factorial over 3 factorial.
No, we're doing C74. C74. So numerator is not going to be 4 factorial.
7 factorial.
7 factorial over
3
3
factorial
factorial.
and 4 factorial.
factorial, right. So to simplify, you would combine these two, the larger one in the denominator, that becomes 7 times 6 times 5, and then expand the factorial 3 times 2. You don't have to write the 1. 3 times 2 is 6, that cancels with that. So 35, 7 times 5, 35. C74, and then let's go to part B, C41. This one, that's 4, right? We just saw how to do that. C41 is 4. C44 is 1. 4 objects given, all 4 of them are being chosen. Only one way to do that. C52.5, we have to simplify using our formula. 52.5. Okay, numerator will be 52 factorial. Denominator will be 52 minus 5, which is 47 factorial, times 5 factorial. And then to simplify, you had to combine the 47 factorial and 52 factorial. Individually, you cannot find 52 factorial using your calculator, and you cannot find 47 factorial. You have to use this method. 52 factorial over 47 factorial simplifies to 52, 51, 50, 49, 48. And then write 5 factorial expanded. and then simplify everything. So 4 divides the 48 into 12, and 5 times 2 is a 10, which cancels with the 50 to give you 5. 3 divides 52, 3 divides 51, actually, yeah, 51. Doesn't matter which one you divide. 3 divides 51 into 117. So the finally 52 times 17 times 5 times 49 times 12 is your answer. You have to use calculator to multiply them. This is the only way to simplify that. If you try to find 52 factorial in your calculator, it won't work. It'll be overflowing. Okay, so now the permutation, we learned permutation and combination. So the thing in the application problems, when it comes to application problem, you have to decide whether it's a combination problem or permutation problem. So the rule is this: does the order matter? Are we counting rearrangements, or are we counting just the number of ways of selecting? Are we counting selections or rearrangements? That's the question you need to ask. And it can be difficult. Students very often go wrong with that, but only by practicing you can learn that. So let's do this exercise 6, which is about determining whether the problem is a combination problem or permutation problem. Okay, determine whether the following are permutations or combinations. Question A: number of ways of taking 2 books from the shelves of a library. In a library, you're taking 2 books from the shelves. The number of ways of taking them. Would that be a combination or permutation?
Permutation?
No, it's combination, because you're just taking 2 books, so it's number of selections. You're not rearranging those 2 books. I know it's not easy, but you have to pay attention to the details. So first one is combination, not permutation. Second one says number of ways of planting 5 different plants along the fence. Anyone?
Permutation?
Combination.
Because now you're arranging. There are 5 different plants, and planting the azalea first and something else second is different from planting the azalea second, right? So the order now matters. So how many ways are there to plant? That'll be permutation. So the answer to, if you're doing this as an actual problem, part A will be combination of whatever the number of books are there in the shelf. Let's say there are 50 books. I mean, if it is actual problem, they will give you the number. 50 books are there, I'm choosing 2. So it's combination 52 for the first one. Part B is 5 plants are there and you're planting them along the fence. So now you're arranging the 5 plants. So the answer will be B, 5, 5. Permutation of 5 plants given 5. C is going to be number of ways of picking 3 students from the class to serve in a debate team. You're making a debate team of 3 students. And the class size is, let's say, 20. From a class of 20, you're choosing 2 students to, or 3 students to make a debate team. So would that
Combination?
be? That's a combination. Why? Because the debate team means 3 students together. A different arrangement of those three students is not another team, right? So you have to look into the context of the problem. Debate team means just 3 people together. Another arrangement of those 3 people is not another team. So therefore, number of ways of combining 3 objects from 20, whatever the class size is. So that's C23 will be the answer. Part D is number of ways of picking 3 students from a class to serve as president, vice president, and secretary in the student government.
Permutation.
That's now the permutation, because you are placing them in those offices. That means the order matters. Who is the president, who is the vice president matters. So now the order matters. So therefore, now it is class size, comma, 3, but permutation. Part, yeah, that's all the part D is. All right, one more exercise and we can quit. Exercise 7. From a deck of 52 cards, a hand of 5 cards is dealt. How many hands are there is the question. Is that permutation or combination?
Permutation?
Combination.
Okay, I heard 2 answers. Combination is the right answer because when you give from 52 cards, when you give a hand of 5 cards to one person, that is just a selection of 5. A rearrangement of that 5 is not being counted here. A selection of 5 goes to one person, another selection of 5 goes to another person. So this is a combination. We are not rearranging. Order doesn't matter. The order of the 5 cards given to one person doesn't matter because rearrangement will be still the same for that one person. Whatever the hand he's getting is the same hand, even if you rearrange. So in other words, the order doesn't matter. So if it is about team, team or debate team or a competition team, something like that, that's clearly combination. So is there a keyword that would identify permutation and combination easily? No, no keyword. That's a common question students ask me, but no keyword. You had to look at the context. So let me give you one example to differentiate. If the problem says there are 12 songs that Jacob can choose from, and he's going to play on the stage, he's going to sing 5 songs. How many ways are there for him to choose the 5 songs from the 12? That would be combination. The number of ways of choosing 5 songs from 12 would be combination. But the question can be slightly different. And the question can now say, Jason is going to sing 5 songs and he's going to choose that from 12 and he's going to play them on the stage. How many different recitals are there? Now you have to think about the recital. A recital means the order matters. If he sings certain song first and certain other song second, if you reverse them, the recital is different now. So if it is recital and you're counting how many recitals are there, then it's permutation of 12,5. So it all depends on what the question is. So unfortunately, it's not very easy. You have to pay attention to what is being counted and then decide whether order matters or not. Are we counting rearrangements or are we counting just combinations? You have to ask that question. So there are going to be some questions that you'll have to determine whether it's permutation or combination. I'll try to minimize it. We will do some more examples on mixed problems in the next class. And so the next class, we'll do some mixed examples, and I can start answering questions on the practice tests in the next class also, because we have finished with the material. But we need to do some more examples. So that's why I'm reserving next class for doing additional material, because we have done the theory, but we need to practice with some more examples. Other than that, we have finished. So next class we'll do some more problems on permutation combination. And after that, you will be set. And so Monday, tomorrow, next class, Wednesday, part of the class, Wednesday, and all of Monday class will be discussion of your practice test questions. And next Wednesday next week will be your exam. And like I said at the beginning of the class, exam will be conducted in a meeting, Zoom meeting, and in the meeting I have to see you. Otherwise, your test will not be counted. So therefore, you need to make sure your camera will work, and I'll be able to see you while you're taking the test. All right, so that's all for the day, and enjoy the rest of the day. I'll see you in the next class, Wednesday.
Bye, Professor.
Bye-bye. Have a nice day.
You too, sir.
Yeah. If you have a question, hang around. Otherwise, you can leave.
So I just have a question about exercise 7. I just wanted to know if I went about it the correct way.
Okay. Exercise 7. There's a
Yeah.
question right here?
Yeah.
Yeah, okay, go ahead.
So I started off by putting 52 factorial as the numerator, and
Yeah,
then 47 factorial, and then 5 factorial.
yes, it's C combination of 52 comma 5. So it's C 52 comma 5, which is equal to 52 factorial in the numerator and 52 minus 5, 47 factorial times 5 factorial, right?
Yeah. And then basically I just got my solution as like 5,197,000
Okay,
and 20. And I just wanted to know if I did that right because I divided 52, I believe, by 4, and then I divided 51 by 3, and 5 and 2 by 50. I
okay.
just wanted to make sure I was
Yeah,
correct.
let me write them down clearly. 52 times 51 times 50 times 49 times 48 times 40, not 48, that's it. Divided by 5 factorial, that's 5 times 4 times 3 times 2. So you divided what again? 5 by 50, 50 by 5?
I divided 5 and 2 by 50.
Yeah, okay, that's 10. Okay, and then,
I did 4 divided by 52.
okay,
And then 3 divided by 51.
okay. And then 2 goes into 48.
Oh no, I combined it 5 and 2. Make
5 and
by
2,
5.
10, and so that's a 5. Okay, got you. So that's 13 times 17 times 5 times 49 times 48. Is that what you multiplied?
Yes.
Okay, it's fine. You got it.
Okay, thank you.
You're welcome.
Have a good day, Professor.
You too. Bye-bye.